In this box, I have the most secure device in this building, even with all these IoT people here today. In fact, I would say it's the most secure device in the country. This device has never been penetrated. It's been used as an attack vector before, but it has never, ever been penetrated, and I would say it never will be. It's the gold standard for IoT security. And we're going to get to that in a minute. Today we're talking about practical IoT security and what makes it so practical. I promise we will talk about that. We're also going to talk about connectivity. Practical. Let's talk about what it means to be practical in IoT security. Because a lot of times we talk about the pie in the sky and we talk about devices like this that are completely impenetrable. But too often in IoT, we see the exact opposite of this device. Let me give you an example. There were two boys playing in the Arctic Circle, and they're just sort of running along, and as they're running, they look behind them and they notice that they're being followed by a polar bear. And so, of course, they start to run faster. One boy stops, and he starts putting on a pair of ice skates. The other kid looks at him and he says, "What are you doing? You know a polar bear is way faster than ice skates. You could never outrun that polar bear with ice skates." And as the kid skates away, he looks back and with this confused look on his face, and he says, "I'm not trying to outrun the polar bear. I'm trying to outrun you." So many times security is that way, and especially in the state where the IoT is right now, is that, yes, it would be great if we could outrun the polar bear, but sometimes we look at that and we say, it's impossible to outrun the polar bear, so we just lay down and nothing happens, and we don't properly do any security. And so very often, we've been talking about this whole conference. I've had a lot of different talks with people about the low-hanging fruit. And let's not be the low-hanging fruit. So for sure, let's make sure that we're not the guy running in tennis shoes from the polar bear. And so, you know, that sort of analogy comes up a lot and comes up over and over again. As we dig into that, I want to talk about a set of myths. And these aren't just myths these are real life things that I hear from people, that I see people doing day in and day out. And the first one is that I'm too small. No one would want to attack me. I don't have enough servers, or our company isn't generating enough cash yet, and so no one's interested in me. Okay, that's false, because that's not how attacks happen anymore. Most of the time, someone is not targeting you. They're doing this low-hanging fruit thing. It's the polar bear. If you're in the way, you get caught, right? And so this idea of, well, I can kind of get away with some things because no one's targeting me, it doesn't work that way anymore. They're launching attacks across devices and those kinds of things. We'll talk about some of those things here shortly. The other one is, and this one's going to sound really stupid when you say it in a presentation. I hear these things all the time. I'm like, who does that? And that is, no one's going to notice this vulnerability. And who in the world says that? But the truth is, we do that in our actions. So as developers, we open up a debug porter. We open up some aspect so that we can track our own device or figure things out. And we think, well, it's not that big a deal, or we'll take care of it later. And that's number 3. We'll get to security later. Okay, come on, we've been doing this long enough. We've been running businesses long enough. We're not getting to anything later if we don't prioritize it. And so, as I talk to you today about practical IoT security, let's talk about some of these things that we can do. I want you to leave, when I think practical, I want you to leave with things you may be able to go back to your company and start implementing immediately, or change things that you could tweak immediately that will make a serious impact on your security. And so why might you not solve security? I mean, you know, it costs money to solve some of these things. It costs time. It's an investment, right? And so ultimately, security is an economics problem. If we didn't have to deal with the economics, we would just infinitely do security, and then we would have this pinnacle of security for all of our devices, right? So in part of that practicality, we have to realize that economics come into play. I wouldn't spend $50,000 to just secure $100, right? That just, it's not practical. It doesn't make any sense. And so the good news is, the good and the bad news is, that the internet of things is solving this problem for us, right? And so you're probably all familiar with Mirai. So Mirai comes out last year. It hijacks. Initially, they thought it was 145,000 devices. Estimates go as high as 1.5 million devices. They got hijacked with Mirai, and now your device is being used as an attack vector for other things. And so your device that you put your blood, sweat, and tears into is now attacking other things. So this is part of solving that economics problem. The internet is solving it for us, right? I talked about this device that I have here is the pinnacle of IoT security. Never been breached. And frankly, we would like our devices to be like that. So the other good news is that today you can not bother to secure your device at all. And for 100% for free, the internet will secure it for you. This is not a sales pitch. This is not a thing I'm doing. This is something just in the beauty of the internet. Because the most secure device you will ever see is a brick. There's no Ethernet connection. There's no Wi-Fi connection. There's no connection to this device. We don't have to worry about what kind of processor is on it. And it has been used as an attack vector, mostly on Windows. No offense to the Microsoft people. But this really is the pinnacle of security. There's no way you will ever breach it. But it has no features, right? And so we're always working this compromise of what features can I get in versus how much do I open my device, right? Very often, the innovation that you're creating is the Achilles heel that you have from a security standpoint. So as I was saying now, the internet has a solution for you, and that is BrickerBot. So BrickerBot comes out a few months ago. And now if your device is unsecured in various and several ways, BrickerBot will go out and infect your device, use your device to infect other devices, and then when it's done, it will brick your device, render it completely useless. Your firmware update mechanisms don't work. Your features don't work. All of your customers have a brick that they paid however much they paid for your product. And now the only thing that it can do is keep doors open or possibly break windows. So 2 million devices were infected by BrickerBot. So when we talk about the economics problem, the internet is solving the economics problem for us. Because if we aren't securing our devices, then the internet will secure our devices, but not in the way we want to see our devices secured. And then of course the next logical step of this is one that several, we're talking and going, why didn't anybody think of that before? So now they're taking your devices and they're mining Bitcoins with them, right? And so that had to happen. That had to come next. So, okay, so we're having some fun today, but I want to talk about some really serious aspects of IoT security. That's enough joking around. Let's talk about some really serious. Somebody hacked my presentation? Okay, chocolate cake, leprechauns, and 3 musketeers. Talk about IoT security. Go, let's do it. Actually, it really is security. It really is serious, and I want you to remember it. So let's use some visual aids and have some fun and see if we can remember this. So the first thing that I want to talk about is that you really need to start with security in mind. You've got to bake security into your process, into your product from the beginning. It's something that you've got to be thinking about. It's got to be part of your culture. It's got to be part of your mindset. And if you do that, you know, I was at a security conference recently where somebody said, well, if you think about security at the beginning, then security is free. Okay, it's not. It's not. That sounds good. It's not. It's work, right? There is effort. There is an economics piece of security. But the truth is that sometimes security is free if you think about it at the beginning. And I'll give you a quick example. So passwords, the way we store passwords, we used to just store your passwords on the server. And then we found out every once in a while someone would get access to those, and now they have our passwords. So now we do something called password hashing. We'll talk about what it is in a minute. But it's a one-way algorithm where we store your password in a format that you can't easily roll back to what the initial password was. And so, for example, if we have security in mind from the beginning, when we go to roll out passwords in the cloud or whatever we're doing, we may initially, our default would be just, well, I'll use whatever the framework has. I'll use whatever my device has built into it. I'll use whatever's there, right? And so by definition, you're going to get average security that way. Maybe you're with a framework that's really good or a platform that's really good. Maybe you're with one that's terrible. If you don't think about it, you're guaranteed to get just whatever's handed to you. If you think about it, then it's very easy to go out, Google and find, okay, what is secure for this? What have people come up with that is better? What's a better way to solve this problem? And so now suddenly, instead of using one framework, I use another framework, and I use one that's more secure. And so that really was free. I just took a few minutes to go work that process of thinking through the security, right? And so if we think through the security, make it part of your process, and sometimes it really will be free, right? And so we can help our own economics problem. If we make this part of our culture, part of our mindset, and something that we're actively doing all the time, then sometimes we really do get it for free. Okay, let's talk about chocolate cake, because who doesn't want to talk about chocolate cake? So I'm not a big cake person, but one thing that I know is the more layers you put into a chocolate cake, people seem to like that better. So for whatever reason, a 7-layer cake is amazing. I don't know, it sounds all the same to me, but I do know why it's better to layer your IoT security. And so what we found is we used to just say, well, I'm going to put up security, and then I'll be impenetrable, and then everything will be fine. And we started realizing, no, we're getting penetrated. That first level of security we often think of as the passwords and our password tables and stuff, right? And we've seen password dumps from MySpace, from Dropbox, from Yahoo. We've seen hundreds of millions of users whose password entries have been dumped. And so what's your second layer of security? If you believe your first layer of security is impenetrable, then you're not going to put as much time and effort into your second layer. And so never assume that that first layer is impenetrable. Always build in layers of security. This should be a part of your thought process. A part of what you're doing is working through the layers and making sure that you're layering a security solution, that you're always assuming each layer, don't build it to be penetrated, obviously, but assume it will be. What happens next? What happens in that next layer of security? Okay, so brief lesson from Leprechauns. Everybody knows how Leprechauns work, right? They hide their pot of gold at the end of the rainbow, right, okay. So one person in here is familiar with Leprechauns. By the way, this is a double bow, which is pretty awesome. The outside one is inverted. Cool physics stuff that you're welcome to go Google later. So the rainbow, so we have this security problem in IoT that has to do with rainbows as well. How many people have heard of a rainbow table before? A few people? Anybody never heard of a rainbow table or heard of one and not really sure what that does? Okay, awesome. So I always feel like it's easy to talk at all these things high level, but then where does the rubber meet the road? What does that really mean? What really happens there? So let's dive deep quickly. We won't get all the way to the bottom of the well, but let's dive deeply quickly into one aspect, one piece of this, and see how these things can work and do work in the real world, right? So I talked earlier about password hashing. And password hashing, sometimes you'll hear it as they'll say, well, we need to encrypt our passwords. It's not really encryption, it's a form of cryptography, but it really is hashing. And so we're going to hash a password. So let's take a look at how this works. we're going to skip over some of the math behind it, but generally, I have a password. So here, my password is password. That's hash 2, for example, 3A6F2. That hash really is much longer. We're going to just cram it in here and take a shorter version. But you'll get the idea. So the next password's an awesome password, but it hashes to something that looks very similar. So it doesn't matter what your password is, the hash is going to come out looking similar, but being a very different hash. Now, this algorithm works to take your password and turn it into a hash. It does not work in the reverse, right? And so a quick example of that is if you remember grade school division, and we said, what's 7 divided by 4, right? It was 1 remainder 3. If I gave you remainder 3, could you tell me we divided 7 by 4? No, because maybe you divided 11 by 8 or any of an infinite number of other numbers, right? You can't go backwards. You can't get the other one from that one. So that's kind of how hashing works. And so we said, okay, this is going to be great. We're going to make these hashes, and then if someone gets our table, they'll never be able to go backwards and figure out how to get the password from the hash. And so someone is always going to solve these problems, right? And so as we make things more secure, someone on the other side is going to make them more penetrable. And so they have what's called a rainbow table. And this is our rainbow table. It has the passwords. I happen to have them over here on the right. The way we generate it is we take crappy passwords, like 1, 2, 3, 4, 5, password, 5, 4, 3, 2, 1, QWERTY. Okay, quick, nobody look. But if anybody has one of these passwords, please get up, leave the room right now, and change your passwords, all of them. All right, nobody's looking at you leaving out the back of the room right now. Okay, so we take all these simple passwords. In my case, fine, we have 4 of them, and that's not that interesting. In a real rainbow table, we would have millions and millions of entries in the rainbow table. Turns out, PowerPoint, millions and millions of entries, font is very, very small. So here, we've turned these into the hash, because that's an easy thing to do with this algorithm, right? So now, through the magic of our PowerPoint, let's bring back our table. This is what the hacker would get if they were to dump our table. They would get this along with the usernames that go with it. And so what I can do is I'm going to look this up in the table. I don't have to go compute it anymore. I'm going to go look it up. So 3A6F2, is that in my table? Sure it is. So I see that that first entry was password, as we may remember from the first table. Now the second one was my really good password that hashed at F37, whatever it is, right? So is that in my rainbow table? Well, no, it turns out that's a really good password. So it's not in my rainbow table. Okay, didn't get that one. But from a bad actor standpoint, they're trying to get as many of these things as they can, right? And so we go through the list, and there's that one. That password was 1, 2, 3, 4, 5. The last one was a very secure password, so they can't find it. And so this is how they created rainbow tables to defeat password hashes. So what do? So now there's an algorithm. It's been out for a very long time, actually, but there's an algorithm called bcrypt, which is great at this because it includes what we call a salt with the password to create the hash, and the salt is different for every single password in your database. So now this one-size-fits-all bit doesn't work, and so it defeats rainbow tables. So this is one of those places where if we stopped and looked quickly, we could find an algorithm like bcrypt that we could use that defeats a simple attack like a rainbow table, right? And so these are the kinds of tangible things that we can solve. Unfortunately, this is the problem with security, right? There's a whole host of those things. There's a whole stack of those that we need to deal with. But this is an example here of one specifically that we can deal with. So thinking about mentality and things that we can do from a mentality standpoint. So this is avoid the 3 Musketeers. Because as everyone knows, the 3 Musketeers slogan is one for all and all for one. All right, 2 guys know. All right, so it turns out all for one, really good for Musketeers, not so good for IoT. And so we actually see a lot of this where you create a device and you put some mechanism to secure that device on it, a key so that only that device can get into your network. And then you create 20 million of these, which all have the same key on this. Somebody was telling me last night, actually, that they were working with somebody who designed that in. They were thinking about, let's make sure everything has the same key on it. So here's the problem is when I ship my device out, somebody takes that, they open it up, and they get the key out of it. Now they have the key for 20 million of my devices instead of having the key for one device. Does that make sense how if everything has its own unique key, then you only have one device compromised? If I want to shut off that one device, I can. If they were all the same, my choice is let you keep hacking me or shut off every device that I just shipped out of my fleet, right? So just a simple thing that I want to share with you in terms of mentality and mindset, things that very easily we can solve. Soon as you ship out that single key, you lose control. You lose control of your device, you lose control of your security. It's all out the window. The last thing that I want to talk about, and this is sort of the IoT gift that keeps on giving, and that is firmware updates. And whether your device is running firmware, software, whatever we want to call it, it's important that you're updating your devices, that you build in, again, so this is one of those things from the beginning. If you push out devices from day one that don't have a way to update them, then you can't update them with a way to update them in the future, right? They've got to ship from day one with a mechanism to update them. Not only to update the software perhaps that you wrote on your device, but what about the other software on the device? What about any third-party software that you're using on the device? What if your device runs on an embedded Windows or Linux platform? Can you update the operating system behind it? What happens when there's a zero-day vulnerability in the operating system? Do you have a way to update that, right? And so it's important to build in a mechanism from day one that will allow you to update your firmware. It will allow you to push those updates out to your users so that you can, not only for security holes, but it turns out it's really useful for pushing out new features, right? Was it Sarah that said earlier that innovate after installation, right? And if you don't have a way to update your stuff once it's out in the field, then there's no chance for you to innovate once it's out there, once you find some of those other things. And so you really need to make sure that you have a firmware update mechanism that you bake in from day one. And so just talking about what some of these practical steps were, right? Bake in security from day one. And if you don't start with that, then none of the rest really matters. You've got to start with that. Make sure that you always layer. Don't, we can very easily just call it what it is. We get arrogant about it, like no one's ever going to get through this layer of security. Okay, awesome. Then assume that they are. What happens after that, right? And so make sure that you're laying your things. 3 Musketeers, all for one for all, really good for Musketeers, really bad for IoT devices. So as a particular thing, make sure you're not handing out a key to the city that goes out with every device you ship. And in fact, as you're thinking about, we talked about making security part of your culture and part of your mindset. This is one of those things that your device is going out. You're going to actually hand your device to the bad actors, to someone who may want to hack you or whatever. They'll just go buy your device. And so once they have your device, or if they don't buy your device, if you're doing, say, a smart city, anybody can climb a pole and take one of those devices, right? And so, again, don't assume that they won't get your device. Assume that they will get your device. And if they get your device, what can or what can they not compromise? So be thinking about that. And for anything you didn't think of, then that's why we want to make sure that we have the software and firmware updates so that we can go back to that thing, we can handle it, we can solve it after we've already deployed it to the field. And so a good software firmware update mechanism is absolutely crucial. And so we just jumped into this right from the beginning, but in case you didn't read the opening slide, I'm Brian Geisel. I'm the CEO of Geisel Software. We're a software development company that works in the IoT. And so we do device software, we do cloud and mobile software. And so that's where a lot of this is coming from, is working with different clients and folks who are really deploying those devices, connecting them either over Bluetooth to a mobile app or via the cloud, via Wi-Fi or some other mechanism, and dealing with those security issues from top to bottom through that stack. So I think we've got a minute or two before the next session starts. If anybody has any questions from that, I'm happy to answer questions if anybody has any.
fills out the little piece of paper, goes to your website, registers, they just don't get updates, you know. Would it be better to add in some sort of, you know, when you set up the device initially, ask for your email type of situation?
Yeah, so his question, you can tell me if I'm not characterizing it correctly, but you know, what's your recommendation in terms of firmware updates and someone having to go and manually register? You know, you get the registration card in every product you've ever bought, and I've never sent any of those in, right? And so how do you do those updates? And so what I would say is, and what we're seeing in all the devices really that we're working with people to deploy, is that you make sure that it's an automatic update mechanism. And sometimes, you know, there's some mission critical devices that you need to work a way around the client's schedule or whatever that is, so that you can do updates in a way that won't impact the power grid or the hospital or whatever that is. But ultimately, you have to find a way. Maybe there's some way that a user can confirm. Maybe there's a time slot that you can do, whatever that particular is. But the crux of it is make sure that it's an automatic update mechanism. And you know, you even get into places where the device if the device is sort of a Wi-Fi device, an Ethernet device, something that gets to the internet, that's a little bit of an easier problem to solve. We do that pretty regularly. But if your device is on Bluetooth or on something else that's not necessarily connected to the internet, but connects in some other way, I realize we're at a conference about Internet of Things devices, but you may have some other form of connectivity. Sometimes you'll need to even put in a hub in between that is there just to allow that process of automatic updates. Does that answer your question? Okay, awesome. Anybody else?
I don't know if you have already answered this question, but like, so I have a device, let's say, and the device needs to transmit the data to the cloud.
Yep.
So, and the device is running some kind of program. So, end of the day, it needs some kind of keys or authentication that needs to happen to talk to the cloud. So that's sitting in that device, the program, and it's practically sitting in the device in some location.
Yep.
How do you, like, what kind of authentication mechanisms are there available that I need not store the keys, or end of the day I'm storing some kind of user ID and password or some kind of keys kind of thing, so that it
Right.
can communicate to the cloud.
Right.
I don't know how can I restrict that.
Yeah, no, that's a great question. Okay, so his question is, I've got this device, okay, I've got it out there, and I'm not going to assume that a bad actor doesn't have access to my device. What is the mechanism that I use to communicate to the cloud? How can I do that securely? And how can I protect those keys and make sure that it is that my device is talking to me? Is that the question? So every single answer in the IoT, I feel like, begins with, it depends on the device. But a portion of that is, you know, like we talked about, the first one is make sure that everything has its own unique key built into the device, right? And then the next piece is that key might even end up being a certificate. And what you might end up doing is signing your connections between you and the cloud. So if you need to make sure that it was that device talking to me, and the device needs to be sure there's not a man in the middle, that the cloud's talking to you, we can sign things both ways and make sure that things are originating from whom we think they're originating from. Now the question of, do I have this key on this device, and someone takes that key, now they can masquerade as the device, right? They can just plug that into whatever machine they want to use to now try to use that as an attack vector. And that's one of the things we face in the IoT that we didn't previously face in like the PC revolution, where PCs were getting connected and those things, because now we're handing this device directly to someone who can now use it to infiltrate us or try to infiltrate us. And so one of the options there is starting to come from hardware manufacturers. And so there might be, I'll look around as I say that to look for the guy doing this is the hardware manufacturer in the room. You know, ARM and other companies are building things in at the chip level so that you have this private key that's actually part of the chip that never meets the software stack. And so if I take the device and I can pull the software stack apart all day long, I will never get to the private key from the device. And so if we need to make sure that it's really the device that's transmitting me this data, then that's a way that the hardware manufacturers are giving us to verify that the the device is who the device says it is, right? Sometimes that, sometimes the worst thing that someone could do with our device is feed us bad data and mess up our algorithm, right? For different applications, sometimes that's the practicality of it. Sometimes that's not worth trying to deal with the lower level issues, or maybe I can't because I'm on a processor that's so low power I don't have access to some of these things. And again, the hardware manufacturers are trying to fix those things. But when I do care, those kinds of solutions are available to protect it from that standpoint. Certainly. Sure.
Do you have a recommendation for, especially for developers, to get started with? Is it the OS 10, or is there in some ways a starting point to keep in mind when you're building security in your device?
So the question was, is there a starting place to use to keep in mind as you're getting into building the device, especially as a developer? And so this one I'm going to give you more of a problem than I'm going to give you a solution here, and that is that the thing about the IoT that is the blessing and the curse of it is that we're innovating so many things. As we innovate things, that new thing that we created can very often become the Achilles heel, because like Dave Miller was talking about yesterday with cars, where he said the Apple guy said, we solved the device problem because we've got it working on the iPhone now, it's a solved problem. And he said, great, so you're going to take your phone and hand it to a random guy as you walk in the bar, type in your password, and then leave it there? And they're like, of course we're not going to do that. And he says, well, that's what you do with your car, right? So now that we've added that innovation to the car, we have a new problem, because what we thought we solved, suddenly that innovation changes it. So the problem answer that I can give you is that it really depends on the space that you're in, right? There are a few things that we're really solving, like we're talking about the key kind of thing, and using certificates and some of those things that are out there and solved. And I think I can say it because they're a sponsor here, right? So Amazon has some great stuff that solves some of that for you. So you can use their SDK on your device, and then you can communicate with them in the cloud. And so they've got some solutions with that. So even just looking into some of the existing solutions that are out there and look at specifically how did they solve this problem will probably give you some good starting points to look into and say, okay, what are people doing with this today? But still keep in mind the way your device works and the uniqueness of your device. And now just think about applying that to the new things that you're innovating in that device, right? Yep. Right, right. Yeah, and so the question was, isn't that a solved problem? And it is probably, I mean, I'm going to just, if I made up a percentage, I just make up a percentage. But well, let's say it is for a large majority of the devices. The issues you tend to run into are, so if you're running a device that you want to run on a watch battery for a month, then you're running on a very low power processor, and maybe some of the existing solutions aren't able to run on something that small at this point. Some of those devices have trouble even just doing encryption algorithms. They don't have enough processing power. Again, the microprocessor guys are solving those problems for us. Some of those, we're still on the cusp of those problems. So it is solved. A lot of those things are solved problems for the large majority of the industry, but there's still devices coming out that are doing different pieces of that. So, all right, well, I want to thank everybody for coming to join us today for Practical IoT Security. I hope it was helpful, and we're almost done here. We got a couple more hours for the rest of the conference, so everybody enjoy the rest of the conference. If you have any more questions or more detailed questions, feel free to stop by and see me. I'm happy to chat the rest of the day about all sorts of interesting things. So thanks, everybody.